this is Stephanie. This is Joel and Amanio. I'm the project manager. Stephanie is also a project manager. They both share the role. Joel is the financial advisor and Amanio is the lead ECE. Our team sponsor is Dr. Oscar Garcia. He's the one who can't be here today. Dr. Michael Frank, he's our advisor and teacher. And Mark Weatherspoon, he also couldn't be here, so Dr. Walana is in his place. A summary, we are doing the oil spill radar. The goal of the project is to have antennas that can detect oil on the water surface. We have to create waves that are lifelike waves like the ocean would have. And we'll have to do extensive research to actually get it in the ocean scale, I guess. But basically, we just want it to detect oil in the wave pool first. In the end, we'll have 2 radars on an arm, mechanical arm that will be controlled from a computer to adjust the angle. We'll also need to accurately capture at least 50% of the transmitted signal in a portable wave pool. The wave generator needs to create 2.8 centimeter gravity-style waves because the wave pool is only about this thick, so they can't go over it. And everything will be tied to a GUI so that we can operate from a computer. This is an overall block diagram. Everything is set up from the previous year's projects. We'll be working mainly with the yellow portion. We'll be doing all of the programming and everything to get the GUI set up. All of the hardware is all set up though from previous years. The linear actuator, this is what controls the mechanical arm. So this is what the antennas will be on. And it has a little electronic portion that we need to program. It has existing programming that we just need to manipulate to get to work with our GUI. Our job is to assemble the antennas onto the sidearm. The antenna motion control will meet the following requirements. Listed here, the motion of the antenna needs to have a 30-degree range. The desired angles will be controlled from the GUI from our laptop. It needs to be protected from the environment, so we have to weatherproof the electronic portion. The antennas in the arm are already weatherproof. And then also the antennas must point at the wave pool. This is a diagram of it. They can hold, the antennas are only about 20 pounds, so the arm can hold all of them. And here it shows how it needs to be able to point down. The wave generator, we already have all the materials and everything from last year. All we have to do is get it to operate. It needs to operate at a frequency of up to 5 hertz. The waves, as I said, must be gravity style, and it must be operated from the GUI. This was chosen by last year's team. It's the motor for the wave generator. It's 12-volt brush DC, and these are the specs for it. The motor selected allows, we can specify the angular frequency, and it will generate waves in the longitudinal direction.
Okay, so with our parts of our project, we have 2 electronic components that need chassis.
Questions or maybe after?
Yeah, you can.
Do you want to ask a question?
Basic questions. You talked of, introduced a few basic terms like Bragg reflection and synthetic aperture. Can you elaborate on that? What is Bragg phenomenon? What is synthetic aperture?
The Bragg scattering?
Yeah, it's back in the beginning. Yeah.
So the Bragg scattering is like based on the permittivity of the water. When you detect the oil and the receive signal, you should be able to see that there is the kind of noise on the water and in the receive signal of the antenna.
So basically, what is Bragg scattering?
Bragg scattering?
What does it mean, Bragg scattering? It's a special type of scattering. What is it?
Go ahead.
Bragg is when you have brass scattering
have the oil on the sea level. You want the signal whether the oil is on it. Then when you receive the signal from the oil, it's just, when you're just measuring things, maybe you have some particles that you're targeting, so the scattering so that the antenna can receive the signal of the particular thing you are going to measure.
See, we are talking of Bragg scattering, not any scattering. What is Bragg scattering?
I guess this is something we'd have to look into more. We're focusing more on getting
Okay.
the programming working.
Second thing is about what is synthetic aperture radar?
Synthetic what?
I'm picturing that.
Synthetic aperture radar, what does
Sorry.
that mean?
I just understood as a type of radar system that Oscar uses.
What is synthetic?
I'm not sure.
I'm not sure either. This is all from last year's
Okay.
team, and we're just trying to get the system they have working. So
I
we
was just wondering whether
haven't
you have, since you put it on display,
Yeah.
just wondering whether you given any thought to it or just reproduced it.
Yeah,
Last year people did it.
It's
Yeah.
good. It's good to make sure you understand, terms you're using, just in case someone has a question about it. So it's advisable to, do a little background digging if you don't know what something is.
Let me answer the question also. All right? Back scattering has to do with the periodic waves.
Okay.
You get a special kind of scattering when you have periodic phenomenon. All right? You get it also in crystals. When you shine X-rays on crystals, they have periodic structures. So there's a very special type of pattern. You are observing waves, not just oil.
Okay.
Okay? In synthetic apertures, you are having a moving antenna which synthesizes the aperture. I don't think you're using that. So that is synthetic aperture. You need to know the terms that we are using, you need to understand what we are doing. Okay?
Okay.
Carry on.
Okay, so in the two components of our system that are controlled with electronic motors, we have the Polio JRK 12B3, which is attached to the linear actuator, and then we have the Polio MC 39926 motor, which is attached to the wave generator. Both of these need to have a chassis to weatherproof them, as long as have pluggable plug-and-play like input outputs. So they need to have holes into the concept design over there that would allow the cables to come out, as well as like maybe seal with a bulkhead to make sure that no water or dust can get in or out. So, next slide. So we were deciding on factors that would have strength, have no permeability, are lightweight, and are cheap cost. So we considered plastic and wood, and the team overall decided to go with plastic since wood is permeable with water. It will eventually over time either rot or like deteriorate. And plastic is also moldable and cheap and easy to work with. A sheet at Home Depot can be purchased for around $28. It's weather resistant and it's lightweight, so it will protect from the rain and dust, as well as remain portable, which meets one of our requirements. So with the programming, we have advertised to the computer science department to add a programmer to the team, since we four are all electrical engineers. A majority of this project would be to rebuild the GUI that was existing in previous years, and all that data was lost. So we have to redo all the signal processing and create the GUI that can be accessed from an IP address. And so we have the student, Bing Wang, who we have brought to the engineering school and showed him our project, demonstrated how it works, and given him sample code to look over. He's very interested and he wants to sign up for this class that will give him credit in the spring. And so we're hoping that he will join our team, as well as possibly another. And so we decided that our system will sample at a rate of 200 kilosamples per second. And this is the ABC that they proposed from last year that allowed it to sample at that rate. So all the code that we have existing does use the sampling rate. And so it will communicate with the Raspberry Pi using these general purpose input outputs that attach in this area to receive the signal. So we will follow the previous year's design using PHP and web interfaces, as well as Linux and Python shell scripts and C++. The user interaction will be on a web browser that is IP accessible, and MySQL is a very popular data storage that has basically infinite storage, and so we will be using that to store our PHP. And for the GUI, we'll be piecing together samples of the code to rebuild the interface. For the antenna motion control, this is also in the GUI. The user will input an X value, which gives the distance that the antennas are from the wave pool and where they want to target onto the wave pool. And so the code will calculate the degree that the position is from the antenna, and the angle will be passed into this motor control function that Polio has in their downloadable drivers. And so the motor will be written in C and reformatted to the pulse modulator, PWM, to control the motor, and then it will adjust. So this is a block diagram that gives the step-by-step on how we plan on going on adjusting the angle of the antennas on that electronic component. And then the wave generator is also the same brand, Polio, so we're going to follow the same process as the actuator and adjust based on how the actuator performs from coding. And so basically with the wave generator, though, they will input a frequency instead of a distance, and then we'll try to follow the same process to make the wave generator oscillate and create those style waves that we need to meet the requirements. And then Joel is going to do.
So I'll be going over the statement of work. So for the statement of work, we need the Raspberry Pi to be accessible. We also need the GUI to be programmed, and then we're going to work on the antenna motion control, and also the wave generation motion control, and the weatherproof component case. So for the Raspberry Pi, we need to make sure it's accessible, whether it be over a router or a modem, or even directly through a laptop. And it also needs to be accessible through its own IP address. So the approach that we're going to use to do that is to follow the user guide from last senior designs file. And they have a couple troubleshooting ideas just to make sure we connect. So to verify, we want to connect it straight to the laptop and make sure we can connect to that IP address of the Raspberry Pi. Upon completion of the task, we should be able to start programming the graphical user interface, and we also will be able to store the data from the actual satellites. For the GUI programming, we need to create a graphical user interface that will combine all the aspects of the actual system. This includes the wave generator, the antenna control, and the actual data. And it also needs to be inside a browser for any user to access. As she said earlier, we're using the MySQL database, and we're going to use that through the Python language. So for the actual interface, we're going to use the framework from last year. And we also need to include the digital signal processing from the satellites. And we also need to control the linear actuator and command of the wave generator. To test it, we need to verify that each one works independently before we use it, combine it as a system. And we also need to make sure that a typical user can use it without much knowledge, just so any of us can operate it if any of the members aren't there. So this is basically what the interface will have control over. It's going to control the wave generator, the antenna, and the antenna signal. And then from that, it's going to put the data in the actual database. Okay, so for the antenna motion control, we're going to control the angle to the wave's water surface by controlling the receiving antenna, and we need to ensure that the ability to sweep through at least 30 degrees of motion. To do that, we want to get the input value from the distance from the water to the actual satellite, and from that we're going to pass to the motor controller, and it's going to be formatted from the pulse width modulation code to determine what to actually convert it from the analog to digital signal from the microcontroller. So for the antenna motion control, it should be able to withstand both the antennas while in motion, and we should actually be able to see that actuator sweep 30 degrees of motion with the antennas on top. And the outcome of this will be that the antenna motion control will be fully functional, and the data collection of the position in relation to the angle coincides accurately. So for the wave generator, as she said, we need to create gravity-style waves with a frequency between 0 to 5 hertz and a height of 2.8 centimeters. To control the height of the wave, we need to control the motor, and that will be controlled by the angular frequency. For the weatherproof component case, we need cases for both the Arduino board on the wave generator and also on the linear actuator for the satellites. So we needed to design that, which is going to be in plastic. And how we're going to test it, we need to test it without the actual devices inside. Ideas for testing include either like a hose or a shower or some type of rain simulation. And we need to examine it after the rain to see if there's any cracks or leaks. And the outcome of this task is that we'll have a waterproof case for any exposed circuitry for the devices. So this is the test plan for the complete project. We need to set up the test tank in the desired location under the actual antennas. And then we need to confirm that the aiming mechanisms are able to acquire the data from the actual location. We're going to fill up the tank with water. We're going to add the substance that we're actually going to measure for the amplitude of the waves. And then we're going to turn on the wave generator and make sure it's generating at 2.8 centimeters. We're going to test this data and record the data into the system, into the actual database. And then we're going to ensure that the system is recording and storing data at that desired sequence rate.
Question. What type of signal are you handling? What's the nature of the signal?
The nature? We're measuring the amplitude of the actual signal.
What kind of signal is it?
It's a microwave signal.
Is it pulsed? Is it continuous? Is it modulated?
It's modulated. It's a modulated microwave signal.
Can you explain the kind of modulation?
I'm not sure what kind of modulation. I know the antenna translates at around 5.4 megahertz into the wave pool, and it reflects back to the receiver.
That is, you're talking of fixed frequency, you're not talking of modulation. What is it?
It uses
Can you sketch the signal, the waveform?
The waveform. It uses a crystal oscillator to generate the wave. The signal.
Okay.
I'll be talking about risk assessment. It is important. I'll be talking about risk assessment of the project.
Yeah, that's what you're coming to this point. That's fine. That's the next point, isn't it?
Yes, nothing.
Yeah, go ahead.
Yeah, so it is impossible for us to carry out a project without any form of risk. So it is imperative for us to take note of some of the risks that may arise during the course of the project. And one of the risks we have is scheduling risks. Members still need to decide on the technical place and time for the consistency. We need to have a place that we can be meeting at the designated time and particular time, so that in case if any member is not around, then those who are around can take a proper minute of the proper minute of the timing and take proper note of the minute, and when others are around, then they discuss what others did when they were not around. How the budgeting risk. We should try and work in the allotted amount to ensure that the sponsor is satisfied. We shouldn't go beyond the amount that has been allocated. Though it's an existing project, that there's less budget required for it, except for some few things that we have to get to make it work properly. The technologies or devices are completely understood. Due to the technical know-how of some of the equipment that we'll be using, and maybe if the team member did not have a proper understanding of the operation of the equipment, we need to research more on those equipment and get how they work properly so that it will bring forth the efficient functioning of the project. Undefined requirement or constraint. There are some risks that the sponsor might not be able to define, so we have to seek for their clarification for us to know their interests and what they need, so that we can meet up with the requirement and the constraint. The software failure. This risk can occur when testing the Raspberry Pi, which is the thing we're going to use to control the linear shooter. In case the codes are not working properly, then you have to carry out the proper debugging to make sure at every stage that the codes are properly working. And in another case, each member has to take note and keep a record of the code in case if there's a malfunctioning of the code while carrying out the project. Critical design features. Teams should try avoiding any unnecessary features detrimental to the success of the project. Teams should get a well-defined structure from the customer on what features are needed to meet their expectations. Experimentation risk. There is a high probability of risk during experimentation due to the experimental nature of the project when the steps are not properly followed. Like take for example, when you're working on the radar will have the transmitting antenna and the receiving antenna. If the transmitting antenna is transmitting a signal and the receiving antenna is unable to capture the signal back, there might be an improper connection within the circuitry of the radar system. So we have to take note of the experimental risk so that each components are properly connected in the circuitry to make sure that the project is properly carried out. Next. This is the Gantt chart. We are presently at the Milestone 2, and this is what are the research and design for X-band system are ongoing. Next. This is a continuation of the Gantt chart too. And this is the group key. FI is 1, Stephen is 2, GLO is 3, and R 4. So this is the responsibility of each member. So we can assign by the figure for individual 2 members. And this is the budget. We assume that we are being paid $30 per hour. So, and the fringe benefit, the personal subtotal is $430, $200, and the fringe benefit and 29% of personal subtotal. So total is $12,528, and total pay is $55,728. This is the budget. This is the major expenses we are going to do. We are going to buy the extension of the USB cable and the plastic for the waterproof process. And we will also like total of $88. Thank you.
Yeah, let's thank the speaker.
Once again about risk assessment, is there any risk of radiation to the people around? We are subjecting
There's no risk with the frequency we're operating on. I know that if we were to go to X-band, you don't want to be standing right in front of the antennas because that is a higher frequency.
Okay, you mean C-band is safe and X-band is not? Is that what you mean to say?
I wouldn't say it's safe, but it's not like you're not going to get internal thermal from the band.
What to be a little more specific about it? Is it we are subjecting people to microwave radiation, isn't it?
Yes.
How much radiation can a person withstand? Do you have some numbers?
Not sure.
I'm not sure which
And
one.
what frequencies? Just to say that it is C-band is safe and X-band is not,
I wouldn't say safe. I wouldn't stand in front of the antennas. I guess there is an overall risk of radiation poisoning.
How much power are you handling? How much power are you transmitting?
We take 12 volts from the wall and we downset the 5 volts into our system and then we transmit it.
How much is the microwave power being transmitted?
I'm not sure of the actual numbers at the top of my head.
We need to quantify things, how much power, what distances are involved, what frequencies are there. So put in some numbers, not just vague ideas. It's safe or not safe. But we're talking about engineering. Engineering is precision.
Yeah.
Right? How much power can you withstand? Safely. I want a number.
That would be good to research that, yeah.
And that's an important risk when you have data. Isn't it? You don't want to subject yourself to a lot of microwave radiation. Okay, all right.
All right, any other questions? questions from you, Raj? I'll just ask you guys my questions offline at our meeting. Okay? All right, well, thank you guys.
I say, Bud?
Yes.